Alright, kiddos. So here goes a little bit of help with, and this is actually an Algebra 1 skill, but it's called Interpret Basic Exponential Functions, Graphs, and Tables. Alright, so good thing we're not in Algebra 1. I could see with those skills this would be very challenging. But you are in pre-calculus, so you can do it. So, one type of question is going to look like this. They show us a graph. We're given 2 points. And they ask, for which value of x does the function equal 384? So, if we continued this way, way up, and we found where y is 384, we're interested in what is the x value that corresponds to that. So, we know that the basic exponential function is something times the base to our exponent, which is the variable x. So what I have done is, what is this? Describing the coordinates of the point, okay, 0 and 1.5, and then this point up here, 1, 6. So if we actually plug those in to this general form of our exponential equation, what we get from this first one, the y-intercept, is the y-intercept is going to give us a, alright, because anything to the 0 is equal 1, so the y-intercept basically gives us a, and we find that a, or the coefficient, in this general equation is 1.5. So we know, at this point we know our equation is y equals 1.5 times something, the base, to x. The other point is going to give us enough information so we can figure out the base. So we plug in the values for y and for x. Here's y, here's x. And 6 equals 1.5 times r. And so we divide by 1.5, and we get that r, the base, or the common ratio, is 4. So we're going to call this the common ratio. I think that term is familiar to you. If not, it's called common ratio because that is the thing we multiply by every time. Probably heard that in sequences and series in Algebra 2. So, lastly, they're asking us when, oh good, the heater turned off, when y is 384, what is x? So we have this equation that we need to solve, 384 equals 1.5 times 4 to the x, that's a times, that's an x. That's totally confusing, sorry. I divided by 1.5, so 256 equals 4 to the x. At this point, and we're getting to this, but you could take the log of both sides, and then you'd end up with x, and we get log of 256, log of 4, after bringing that down, and then dividing both sides by log of 4. But we'll get to that later soon. But I think that you can just think about this. 256, you're probably recognizing as some factor, or like 2 to the something is 256. But we basically, at this point, you can just say, all right, well, 4 to the first is 4, 4 to the second is 16, 4 to the third is 64, so you're multiplying, right, by 4 each time, and you go, oh, 4 to the fourth is 256, so x must be equal to 4. Or if you recognize this as 2 to something, you could say, well, 2 to the 8th is equal to, and then 4 is 2 to the something also, it's 2 squared, so you have 2 squared to the x. Based on this, because the bases are the same, 8 equals 2x, and you'd get x equals 4 as well. So these are two different ways of thinking about how you'd actually get the answer to this. This is sort of a more mathematical procedural way of taking the log of both sides. This, they'll give you x equals 4, which would be the answer to that question. Okay, next type of question, they'll give you something like this. They say h is some exponential function, so same general form, and they give us some values in the table, and they're asking for the common ratio. In this type of question, they either ask us for the common ratio or the initial value they're going to call a, not the coefficient, same thing. But so I'm a very visual person, so I like to do this, where these are the values of x, right? Because they don't give us values that are right next to one another. They give us -1, 1, and 3. So we know that when x is -1, y is -2. When x is 1, y is negative 50, and when x is 3, y is negative 250. So we know that in going from here to here, that's times r. Multiply by r, multiply by r, multiply by r, and multiply by r. So based on this right here, we could say negative 2 times r is negative 50. That's this. Negative 2 times r equals negative 50. And then you just solve. Divide both sides by negative 2, square root of 25, and we get that the common ratio is 5. We could have done the same thing over here, where we say negative 50 times r is negative 1250, and we divide both sides by negative 50 and end up with the same thing. Common ratio, and so r equals 5 would be our answer. All right, sometimes the common ratio is a fraction. So let's see. This is the same type of question. G is an exponential function of the form, blah, blah, blah. Table list, what is the common ratio? So same thing. I have drawn it out. We know the first and the fourth and the sixth. So I could say negative 486 times r to the third, times r to the third equals negative 144. I instead chose this because it was only going to be r to the squared. So negative 144 times r is negative 64. So I said negative 144 times r squared equals negative 164. I divided, and at this point I saw, hey, those look like perfect squares. That's a perfect square, that's a perfect square. So if I take the square root, I would just get 8 over 12, which reduces to 2/3, and that is the correct answer. If you didn't recognize that, I've got my calculator handy, and you divided, you would get this. R squared is 0.444444444. Repeating, and then if you were to take the square root of that, the calculator is going to say 0.66666666. Answer, yeah, so you take the square root and it'd be like this, and then you'd be like, that looks suspiciously like the devil's number. No, that looks suspiciously like 2/3. If you were still stuck and you were using the TA85, you could use the fraction button and it would give you this. I think if you put 0.666 in there, Khan Academy would. It's wrong. Okay, because that's how they do. H is an exponential function of the form blah, 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 blah. What is the initial value? Okay, so here we're looking for the coefficient, not the base, but we're going to do this similarly. So what did I do? I wrote out this. And notice how I left the space for 0. This is actually what we're looking for. Okay, the initial value, when x is 0, this is going to be 1, and so the value of the function is a. So this coefficient, we can call the initial value, meaning at the beginning, meaning when x is equal to 0. So that's what we're looking for. And I have that when x is 1, y is negative 5, and when x is 2, y is negative 0.05. 0.5, and then x is 3, y is negative 0.05. So you might just recognize, hey, multiply by 10, multiply by 10, multiply by 10. Kaboom, the answer is negative 50. That's a 50. Let's redraw that. 50. Okay, if you didn't recognize that, you'd go through the same procedure. We know we multiply by r, multiply by r, multiply by r. So I think that I looked at these two values here, and I said, all right, negative 5 times r is negative 0.5. Negative 5 times r is negative 0.5 divided by negative 5, and got that the common ratio is 1/10, meaning multiply by 1/10, multiply by 1/10, multiply by 1/10. Notice how that's the same thing as multiply by 10, multiply by 10, multiply by 10. Okay. So this is what we're looking for. A, or when x is 0. So yeah, I should have put an A there. Sorry. Always trying to be crystal clear, not deceptively misleading. Okay, so there's our A, and we know that A times 1/10 gives us negative 5, so we multiply both sides by 10, and we get that A equals negative 50. Okay, You could have also, if that didn't make sense because we did this previously, a times the base to the x. So we found that the base multiplying each time r was 1/10. So we could have said y equals a, which we're looking for, and then 1/10 to the x. And then you could take any of these values, x and y, x and y, x and y, and plug them in, and you'd be able to solve for a as well, and you'd get -50. Okay, so I think that will be helpful. Khan Academy, you got this. Keep it going.